Today we're going to review simplifying radical expressions, day 2. First we're going to start with a warm-up. We're going to go through a review of the things we've covered the last 2 sections of this chapter. So let's start by simplifying our square root of 20x cubed y to the 5th z. In order to do this, we need to find our factors of 20, one of which is a perfect square. So 4 times 5 are our 2 factors. X cubed cannot be divided by 2, so we need to split that into x squared and x. Y to the 5th also needs to be split up into y to the 4th times y, and then we cannot split z to the 1st up, so it stays as it is. Now we can take the square root of several of those factors. So a 2 comes out, an x comes out, and a y squared comes out. We're left with 5x, y, z, all underneath our radical. Again, if we look at our exponents in the original square root, 3, 5, and 1 are all odd exponents, so our rule with the absolute value bars does not apply. If we look at the next one, we're multiplying 2 radicals together. So let's multiply first before we simplify. So we have the square root of 25x squared, y squared, z to the 4th, and then this can nicely simplify into 5x, y, z squared. Next we go to our cube root. We have the cube root of 32, x to the 7th, y to the 9th, z to the 14th. Again, we need perfect cube factors. So my perfect cube factors of 32 are going to be 8 times 4. For my x, I need x to the 6th times x. Y to the 9th can stay as it is. And then z needs to be z to the 12th and z squared. Again, all those exponents need to be divisible by 3. So when I simplify this, I get 2 x squared, y cubed, z to the 4th, and then I have the cubed root of 4xz squared left over. Next one, I have the square root of 20 divided by the square root of 5. Let's divide those first to get the square root of 4, which equals 2. Next one, I have the cube root of 5 in my denominator. So I want to turn my denominator into a perfect cube. In order to do that, I need to multiply by the cube root of 25 over the cube root of 25. Why do I want to do that? Because then I have the cube root of 125 in my denominator. And in the numerator, I have 2 times the cube root of 25. So when I simplify my denominator, a 5 comes out, and then I have 2 times the cubed root of 25 left in the numerator. Moving on, now I'm taking the 4th root. So I want to turn my denominator into a perfect quad. So in order to do that, I need to multiply by the 4th root of 2x squared y over the 4th root of 2x squared y. When I do that, my numerator looks like this, and in my denominator I have the 4th root of 16x to the 4th, y to the 4th, all perfect quads. So 2 4th root of 2x squared y in the numerator. In the denominator, I have 2xy. I can reduce one more time. The 2's cancel out. And there's my simplified answer. Moving on from there, adding and subtracting radicals. We're going to treat the radicals the same as variables. Radicals must be exactly the same except for the coefficients before you add or subtract, which means you're going to combine like terms. So, for example, if I'm going to simplify the square root of 2 plus the square root of 3, I have nothing under the radical that's the same, so my simplified answer is square root of 2 plus square root of 3. They are not considered like terms. Whereas when I look at the next example, I've got constants that are like terms, and then 3 square root of 5 and 2 square root of 5. This square root of 5 is considered a like term. So I do my 4 plus 7, which gives me 11, plus 3 square root of 5 plus 2 square root of 5 gives me 5 square root of 5. You only change the coefficients. You do not add what is underneath the radical. One more to simplify. This time what's underneath my radical is not a like term, so I need to simplify before I can see what like terms I have. When I simplify, I've got my 3, 9 times 5, 80, I want to get 16 times 5, and then 20, I do 4 times 5. So when I simplify each of these, I'm going to wind up with 9 square root of 5 minus 20 square root of 5 plus 8 square root of 5. So doing my order of operations, I add and subtract from left to right, so I wind up with negative 3 square root of 5. Moving on to conjugates. Conjugates are binomials that first are the sum and differences of the same two numbers, and second, the product of conjugates is the difference of perfect squares. So what that means is that if I multiply two conjugates together, which is this part, I have the difference of perfect squares. What are conjugates, you say? They're the same two terms, one with addition and one with subtraction. So notice they both have the square root of 3, they both have a 2, the only difference is one has an addition and one has a subtraction sign. So what is my conjugate of 2 square root of 5 plus the square root of 6? It would just be 2 square root of 5 minus the square root of 6. The only thing that changes in our conjugates is the sign in between the two terms. Conjugates are used to rationalize denominators. So for example, if I look at my denominator, I have a binomial, meaning if I multiply by the square root of 3, I would have to distribute that, which would not eliminate the radical from my denominator. So in order to get rid of my binomial in the denominator, I need to multiply by the conjugate, which means keep my terms but change the sign in between them. So whatever you do to the bottom, you have to do to the top. Now, in the bottom, we have a difference of perfect squares. In the top, we are going to have to FOIL in order to simplify. So in the bottom, I'm always going to take my first term and square it, minus my second term squared. First term squared minus second term squared. That's on the bottom. In the numerator, I do have to FOIL. First, outer, inner, last, so I get 8 plus 2 square root of 3 plus 4 square root of 3 plus 3. I can simplify this. In the numerator, I can combine like terms. So I get 11 plus 6 square root of 3. In the denominator, I can simplify to get 16 minus 3. I can continue to reduce to get 11 plus 6 square root of 3 over 13. And that is my simplified answer because there are no longer square roots in the denominator. Let's try another one. Again, I have a binomial in my denominator, so I want to multiply by the conjugate. Multiply by 1 minus square root of 3 over 1 minus square root of 3. Again, in the denominator, we take the first term, square it, minus the second term squared. In the numerator, I just have to distribute my 2. So I'm going to get 2 times 1 minus square root of 3. We can simplify this. Now, The reason I did not distribute my 2 is because if I look at my denominator, I know I can simplify that. To simplify my denominator, I'm going to have 1 minus 3, which equals -2. Now, I can see that by simplifying my denominator before my numerator, I can reduce my 2's. If you hadn't done that, that's fine. You would have to refactor out your 2 from the numerator in order to simplify. So then when I simplify, I'm going to wind up with 1 minus square root of 3 over -1, which we should rewrite as -1 plus the square root of 3. And that is my simplified answer.